Welcome all to lecture 10 of subsurface exploration, importance and technique involves. So, in the last class we had discussed why geophysical methods one should use, what are the advantages when we go for geophysical methods, particularly related to interpolation requirement whenever you are interested to find out how the different layers are varying horizontally or laterally along the study area. And then particularly same way, if you are interested to go for deeper exploration where routine geotechnical investigation cannot be done. Third is the findings from geotechnical investigation you want to extend to deeper layers, you can go for geotechnical as well as geophysical investigation. So, at shallower depth you can develop some kind of correlation between physical properties you are obtaining from geotechnical investigation and similar properties you are getting from geophysical investigation. So, then same way you will be able to understand the geotechnical properties at deeper depth based on geophysical test. After that we started discussing like what are the different geophysical methods which primarily in used. Considering the number of topics which we will be covering in under this module, I have selected few geophysical investigation techniques which are not commonly discussed. Two among those are seismic reflection survey, seismic refraction survey and other methods as we discussed in the last class. Followed by, in the last class we discussed about what is seismic reflection survey. We also discussed like depending upon what kind of medium is there, depending upon which method we are using, each of these geophysical methods target to measure some variation in the physical properties of the medium, and we consider like this variation is happening whenever there is significant change in the physical properties of the medium, actual physical properties of the medium. So, just by correlating the physical properties of the medium with the measurements of those physical properties by different geophysical methods, we can find out what are the different kind of mediums available at different depths, what are their physical properties available at different depths and so on and so forth. So, sometime we go for shock waves, sometime we go for gravitational properties of the medium, sometime we go for magnetic properties of the medium, sometime we go for electrical properties of the medium and so on. So, based on wherever there is significant change in the medium characteristics, against each of those characteristics, you will be able to detect those characteristics as indication of possible change in soil type, geology type and so on and so forth. So, we discussed about seismic reflection survey in the last class. In today's class, we will be discussing about seismic reflection survey. What is seismic reflection survey? How you can interpret the data? What is happening in seismic reflection survey? Where the reflection is happening? In addition, before starting seismic reflection survey, I insisted last time like depending upon the source which you are using for the development of shock waves, your field record will be dominated by any particular kind of wave, whether it can be like different kinds of wave which we discussed like P waves, primary waves, S wave or shear waves. So, depending upon the choice of a source which you are using to generate shock waves at the source, sometime your ground record will be dominated by P waves, sometime it will be dominated by S wave. This is more important because particularly when you are going for artificial sources, like you have to go for some subsurface investigation at the site of interest where you are interested to use some artificial source. So, the choice of artificial source, suppose if you are interested to go for shear wave velocity measurements, but if you are going for vertical impact load, definitely vertical impact load will be more dominating P wave content. So, in that case your S wave content will be compromised. So, this understanding is very much important considering the choice of source which is going to be used as a for the generation of shock waves. So, the selection of source is very much important. That depends upon what kind of medium characteristics you are interested to find out. So, this understanding is particularly applicable when you are going for seismic methods. So, in seismic refraction survey which we are going to start today, let us discuss further how it works. So, last time we discussed like when we go for any kind of seismic methods, why it is called as seismic method, because generally during earthquakes or seismic activity different kinds of waves has been discussed, like P wave or primary wave, which is causing compression, rarefaction, then S wave, which is causing shearing in the material. Depending upon the direction in which the waves are propagating, both perpendicular direction with respect to the direction of wave propagation, there will be kind of shearing in the medium. So, if it is passing through the soil, so there will be some shearing in the material perpendicular to the ground level if it is horizontal, and then another will be perpendicular again in horizontal plane, but it will be perpendicular to the direction of wave propagation. So, both ways it is causing some kind of shearing, some kind of relative motion between the particles, as a result of which shear stresses will be developing in the material, and then considering the resistance offered by the material, which we call as shear modulus or shear strength of the material, that will govern how quickly that kind of wave will pass through that particular medium. If it is able to provide more resistance, your S wave will be able to pass more quickly. And then we discuss about, like when your body waves, collectively these are called as body waves, because these are mostly contained in within the layer of the earth. So, I was discussing why these are called as seismic waves, because during an earthquake, whenever we put your ground motion recording sensors, so it will be detecting different kinds of wave, particularly P waves, S wave, then P wave sometime again there will be, once the P wave interacts at the interface, there will be another component of P wave. So, that will be called as P wave, SS wave, SPS and so on. And then second thing, you will be having your Rayleigh waves, this is called as Love wave. So, these are the prominent kinds of waves which are generally recorded at any ground motion recording instrument, depending upon the relative position of your source or epicenter. Because it is happening because of seismic activity, the waves is generally classified as seismic waves or seismic waves. So, the first two are called as body wave, the second are called as surface waves. So, depending upon relative distance between the source and your receivers, at times your record is dominated by body waves and sometimes it is dominated by surface waves as well, both are possible. So, when we discuss about seismic reflection survey, we discuss like there will be some kind of shock waves which are generated by means of a source. This source can be an impact load, it can be an explosion, like any kind of any source of which is able to trigger some kind of vibrations in the medium. Of course, depending upon what is the range of frequency content you are interested in, those vibration will be more interested. And second thing, the vibration you are generating, it should have significant amplitude, so that it can be detected at wide range of the receivers which are kept over varying range of distances. So, it can be impact load, it can be explosion, it can be traffic load, it can be other machine operation and so on and so forth. So, explosion can be related to this particular method, you are going for some kind of exploration, or sometimes when you are doing similar test very near to your stone quarries, there also people are using lot of blasting. So, that can also be detected and can be used as source of vibration. So, this is when we discuss about seismic reflection survey. In case of seismic reflection survey also, though we are the objective is to detect the time of arrival of refracted waves, as the name suggests, but more or less the setup will remain same. So, there will be a source, as you can see here. So, there will be a source, there will be receiver, and generally when we are going for seismic reflection survey, we do not go for single receiver, we go for an array of receivers, because the waves which are particularly coming from deeper layers mostly will be detected by receivers beyond some minimal distance. So, this you can call as receiver 1, receiver 2, receiver 3, 4 and so on, n number of receivers. So, again so whenever we generated some kind of vibrations at the source, what will happen? There will be wave path, the direction in which the wave is travelling, and then there will be wave front. So, the size of the wave front will determine like what is the area in which, because of the propagation of a particular wave, the disturbance or any kind of particle movement is happening. Now, same wave front, as it moves deeper and deeper, you can see it will be covering larger area and so on. So, if you only consider these wave fronts, it will continue for beyond distances also. Only thing, like as you are going away from the source, the amplitude of those wave will be significantly less, amplitude will reduce. Another thing which comes into mind, like here we are only targeting for waves which are generated from the source, but what will happen when these waves will interact, like particularly this wave front, when it reaches this interface means too much contrast in physical properties. To give you an example, like V1, Vp1, Vp2, the primary wave velocity or the resistance offered by the material in layer 1 and the material in layer 2, that will decide how much will be your Vp1 and Vp2 value. So, this is like incident wave, and depending upon the angle of incidence, this wave will equally will be reflected. So, this is called as reflected wave. So, up till this we had discussed in last time when we were discussing about reflected wave, and same way there will be another other frequency this wave fronts which will be reaching later stage. So, you can put another receiver here which will be detecting, maybe you can call it as R naught, because initially you had given number from R1 onwards. So, and again another wave front will be there which will be reaching at some other distance, which will be detected maybe by this receiver and so on and so forth. So, because there will be like because of this wave, there will be wave fronts in all the directions. So, you will be actually continuously recording these kinds of reflected wave all along the receiver lengths, not only at the receiver where you have put the waves, but only in order to analyze, you are putting the receiver at known distance. So, you will be able to interpret based on the time of arrival of direct and reflected wave, what will be the thickness and velocities of different medium. Now, in addition to this, right now we are targeting for reflected wave, but in addition to reflection, there will be, because there is change in medium characteristics, change in medium characteristics. So, what will happen? In addition to this reflection, you can call it as like when the wave reaches, some energy will be start travelling towards the surface, while some energy will be travelling downward. So, what will happen if you draw some this thing normal? So, depending upon whether your the medium characteristics are increasing, like medium is getting more and more stiffer with respect to your shock wave characteristics or shock wave stresses. If the medium is getting more and more stiff, what will happen? Once the wave reaches to the bottom direction, like the second layer, it will start deflecting away from the normal. So, if this is your I1, this will be I2. So, if V2 is greater than V1, Vp1, that means indication like medium at deeper layer is stiffer. That will also indicate the value of I1, I2 will be greater than I1, and how much it will be greater than. So, okay, so this will be called as a refracted wave, which will actually travel in another medium with what velocity? So, that will be corresponding to Vp2 velocity, because this is now I mean once it crosses the interface, once the wave crosses the interface, it will go to the deeper medium which is offering more resistance, as a result of which there will be the wave propagation velocity will be significantly higher, and because of this contrast between the medium characteristics, there will be some reflection which is from the interface start again travelling towards the surface and getting detected by the receiver. Second will be the reflected wave, refracted wave. So, depending upon the if the medium is getting denser, the refracted wave will be moving away from the normal. Okay, so this angle I2, that is angle of refracted wave, I can call it as, that will be a function of 3 parameters. First is I, that is angle of incidence, IC I can call it as, okay, let it be I, because IC will be very specific, angle of incident wave which is undergoing reflection and diffraction, Vp1 and Vp2 value. So, depending upon the value of Vp1, Vp2 and I, the direction of Vp, if I draw it here again. So, if you consider the value of Vp1 and Vp2 to be same for different cases which I am going to discuss now. So, if this is I1, that is incident wave, another incident wave at the same location if I am considering, which is significantly like this, where it is I2. So, if I1 is less than I2, it is greater than I2, what will happen? Considering same value, so your wave will start travelling away from the, I mean the value of like corresponding to I1, if this was IR1, as the value of IR2 increases, so this value will also increase. So, this will become this will become IR1. It will be like the angle of refracted wave because of first incident wave, that will become IR2, because the angle is decreasing here, there also the angle of inclination of refracted wave also decrease. So, as per Snell's law, sin I incident over V1, rather than Vp1 I am calling it as V1. So, Vp1 I am calling it as V1, Vp2 I am calling it as V2. So, sin I1 over this will be equal to sin of IR. So, this is the angle of inclination with respect to normal for incident wave, and this is the angle of inclination of refracted wave with respect to normal. So, same way if you consider multiple cases, like each incident wave at different angle, because finally the angle of inclination as you are considering the case, as you move away from this, I mean, yeah, like this is your interface. What I am trying to say here, like some refracted wave from the source, some incident wave at this location will reach maybe at angle I1, but same wave near this location will reach an angle which is lesser than I1. So, the same thing I am going to show here, like as I mean, because the refraction is happening all along the interface, because the medium contrast is medium contrast property is existing all along the interface. So, even the refraction will be happening at the interface. So, depending upon this, it will be like this, depending upon this it might be like this. This is deciding how much will be your angle of refracted wave depending upon the angle of incident wave, keeping Vp1 and Vp2 as same value. So, this is the same thing as at critical angle. What will happen at critical angle, I am calling it as IC of incident wave. What will happen, your angle of refracted wave, angle of refracted wave will be 90 degree to the vertical. In order to see it further, let us go to next slide. So, what I want to say here, it is like this. So, this is your interface, this is your V1, this is your V2. Let us consider maybe some more cases here. So, this is like V3. Now, overall if I am only targeting for refracted waves, I am putting a sensor here R1, R2, this is like you can call it as sensors which are used for seismic refraction or even for ground motion records. At time you can use, at time you can go for micro tremor records also for detecting these. So, when you are going for geotechnical investigations or geophysical investigation, we generally go for geophones. Some of you might have heard of geophones. You put those geophones at regular interval. So, what will happen here? I am putting geophones at regular interval for my ease. Now, what will happen? So, there was a wave which is, I mean, there will be plenty of waves which are reaching here, like this, all are incident waves. Again, this is having some angle. So, all are like okay, some incident angle will be there. This with respect to vertical, yes. So, if I number here 1, 2, 3, 4, 5, 6 and consider like the angle of inclination are I1, I2, I3, I4, I5, I6 depending upon Vp, V1, V2 and the angle there might be an angle which we will call as critical angle. So, suppose like I5 is critical angle. So, as a result of which the refracted wave because of this critical angle will travel along this interface. I am showing you thick here little thick line, so that you do not get confused with the interface. So, this is like refracted wave due to wave this fifth incident wave. Same way, so this is like refracted wave. Now, it is travelling along the surface again because it is travelling at the surface which is having too much contrast. What will happen, again some component of this will again start travelling back to the surface depending upon, again this will be like critical angle I5 or maybe other angle. So, I mean it will be travelling at different these things. So, some might be this will not be there. Okay. So, this is at critical angle which may be detected here, some might be detected at the same critical angle at receiver 1 some might be detected at this critical angle after certain distance. So, again this will be called as IC and so on IC. So, as you keep more and more number of receiver, each of these you can put more number of receivers also here. So, that this refracted wave will be detected by more number of receivers. So, I can call it as R2, R3, you can call this as R4, R5, R6, R7. Now, what will happen to other waves which were not at IC or which are not at critical angle? First of all, we should write. So, this angle IR becomes 90 degree. Now, if you put this as 90 degree, what will happen? Your sin IC, that is critical angle divided by V1, will be equals to sin 90 divided by V2, or sin IC will be equals to V1 over V2. So, that is how you can get to know. That is why I told you, depending upon the angle of incidence, which is you can say here, it is again a function of. So, critical angle will be a function of the ratio of primary wave velocities of both the mediums. Now, there are other waves also, like I4 is there, I3 is there. What will happen? Because the critical angle is less than this, so those will not be, I mean, after refraction, those waves will not travel along the interface, but will travel at slightly lesser inclination. Like this. So, depending upon how much is this inclination, this angle of inclination will also keeps on, like depending upon how much is this angle of inclination, this angle of inclination also keeps on reducing. So, that this ratio is maintained. Okay. So, this another wave which though refracted, but is not travelling at the like at V4, this is another wave though refracted, but not at IC. What will happen? This wave again will reach this interface. So, this interface, if this is your angle I2, I should say here. So, I can take I2I, which is angle of incidence at second interface. So, same process which was happening at this interface will now happen at this interface. So, in order to determine this value of, if in order to have I2 to be equals to I critical at second interface, again sin IC2 should be a ratio of V2 over V3. So, if this is the case, again there will be some kind of refracted wave which will travel at the interface, refracted wave. Again those refracted wave will have some component which might get detected at the same receiver which you had put there. So, again this is like IC2. So, another refracted wave which is not coming from the first interface, but it is coming from the second interface, will also be getting detected at the receiver, depending upon the relative position of those receiver with respect to different layer thicknesses from which refraction is happening. It may be possible some the refracted wave from deeper layers may get detected by a receiver which are kept closer to the source, and if the depth is more, it might be possible that the refracted wave, before it reaches the ground surface, it may not be detected by the receivers which are kept very close to the source. But overall it will be like so. So, you will be having refracted wave from first interface, you will be having refracted wave from second interface, and so on and so forth. Like this one, if you consider third one, it is not happening at critical angle for this interface. So, again this will again start travelling. Again, so it will again start travelling. So, what is happening overall, I can say, like, because shock waves will have reflection at interface after which wave will travel upward or towards ground surface and detected by receiver and detected by in addition there will be refraction which is happening. So, there will be like two components, one after refraction waves travelling downward because like angle of incidence was not equal to the critical angle at the interface, angle of incidence at any interface n was not equal to the critical angle at that interface. So, we will start travelling downward and getting refracted at later interfaces. And the next one is again there will be refracted wave at critical angle which will be refracted travel along the interface and then upward and getting detected at geophones. So, overall all the geophones will detect. Now, let us see if you know, like this is your source, this is some receiver which is actually detecting your. Okay. Before going to this, I would like to highlight like seismic refraction limitation is, I can highlight here, you understood, like your V2 value should be greater than V1 value, otherwise though refraction will be there, but the refracted wave will never reach to the surface and thus will never be getting detected by the receiver. So, that is why this is limitation, this V2 value should be greater than, otherwise refracted wave will not be detected at the receiver. So, if you are not detecting, if you are not able to detect it, you will not be able to determine or quantify the physical properties, you will not be able to determine the thickness. So, no thickness and no subsoil properties. This has to be kept in mind, otherwise seismic refraction survey will not work. So, this is a limitation I would like to highlight here, that is why I have written simply here. Now, I am considering one wave, I am considering a case where the wave is there which is travelling at critical angle, travelling along the interface and then getting detected at the receiver 1. So, if I number here like A, B, C, D, you consider the thickness of the medium, the layer is H, this is V2, this is V1 and you have kept both the source and the receiver at known distance L. Now, the time of arrival, so again there will be two waves, one is called as direct wave which will be T suffix D. So, that will be equals to AB divided by V1, that is L divided by V1. Then for time of arrival of refracted wave, that is T suffix RFR, can be quantified, can be estimated as TRFR will be equals to AB, in which the wave is travelling with V1, plus BC, in which the wave is travelling with V2, plus CD, in which the wave is travelling again with V1. Now, we know the value of AB will be equals to value of CD, considering the interface is horizontal. So, you can call it as twice AB divided by V1 plus BC divided by V2. Now, again we consider sin IC will be equals to V1 over V2. In that case, AB will be equals to how much? AB will be equals to H divided by cos IC, and BC will be equal to L minus twice H tan IC, like this is the thing. This is IC, this is H. So, this will be equals to AB, which will be equals to H over cos IC, and this will be equal to L minus twice H tan IC. Okay. Okay. So, this is like this, again I can put it here 2 times AB, that is H over V1 cos IC, plus BC will be equals to L minus twice H tan IC over V2. Okay. So, just take L as common here, I can call it as L over V2 plus twice H, within bracket I can call it as 1 over V1 cos IC minus tan IC over V2. Okay. So, that is how if we solve it, you will be able to understand here L over V2 plus twice H, that will be equals to V2. So, again I wanted to highlight here, if sin IC equals to V1 over V2, cos IC will be equals to square root V2 square minus V1 square over V2. So, I can put it here, and so on will be about tan IC. So, that will be equals to V2 minus V1 sin IC over V1 V2 cos IC. Now, I can put the value of sin IC and cos IC, I will get here L over V2 plus twice H V2 minus V1 times V1 over V2 over V1 V2 square root V2 square minus V1 square over V2. So, this get cancelled, you will get here L over V2 plus twice H V2 square minus V1 square over V1 V2 square root V2 square minus V1 square, which can further be solved as L over V2 plus twice H square root V2 square minus V1 square whole square divided by V1 V2 square root V2 square minus V1 square. So, this get cancelled, you will get L over V2 plus twice H V2 square minus V1 square over V1 V2. Okay. Now, this is again referring to TIF RFR, that is time of arrival of refracted wave. Now, if again at critical distance, just like critical angle, at critical distance we call it as DC, what will happen that the direct wave which is coming along the surface as well as refracted wave which is coming from deeper layers, first layer or first interface, will reach the receiver simultaneously. That is, time of arrival of direct wave will be equals to time of arrival of refracted wave. Now, the time of arrival of direct wave we know it will be equals to how much? L over V1. So, the equation which we had calculated here, we can call it as number 2. So, equate equation 1 and 2, equate 1 and 2, equations 1 and 2 should be equal at L equals to DC. So, put that, so you will get DC over V1 equals to DC over V2 plus twice H. That further equation can be solved at as 1 over V1 square minus 1 over V2 square. So, you can take this DC as common, 1 over V1 minus 1 over V2 equals to twice H 1 over V1 square minus 1 over V2 square. Okay. So, that is how you can get the value of, if you solve this equation further, you will be able to get the value of DC, that is twice H equals to DC square root V2 minus V1 whole square over the square root V2 minus V1 V2 plus V1. So, that will give you the value as DC V2 minus V1 over V2 plus V1, that is the value of H. So, this is, you can call this way where H is thickness of first layer, thickness of first layer. Same way you can determine, the approach will remain same, but you will be able to determine the value of second layer, third layer and so on and so forth. So, the value of DC, you can, how you get the value of DC, you will be able to get the value of DC based on your distance time curve, because I mentioned like when you go for field recording, this derivation I showed for one wave front, wave, if you put more number of receivers, so each of those receiver will be detecting different waves coming from different interface, but because the value of V1 and V2 are constant for each wave, so overall the wave which is coming from first interface will give you the characteristics of first interface, whether it is detected by receiver 1, 2 and more. And second, I mean similarly the wave which are refracted and coming from second interface will give you the value of V2, whether it is from R1, R2 or overall from R1, R2 and so on. So, overall first, so this is now one question which comes to our mind is, once we have a number of receivers which are detecting the wave, how you will be able to distinguish whether the wave detected by the receiver will be a direct wave, reflected wave or refracted wave. So, in order to understand that, we have to understand like in terms of physical parameters and the variation of these parameters, you can call it as direct wave, time of arrival, that is Td, that will be called as L over V1. So, it is simply as you keep on increasing the distance, it will be linearly dependent. Then you have reflected wave. So, if you remember last time we had written also RFR, that is equals to square root 4h square plus L square over V1. Third one is refracted wave, which we discussed today, that will be RFR will be equals to L over V2. The same thing, once you know the value of h, you put it back. So, you will get the value of RFR for any distance. I mean, if your receiver is at any distance other than critical distance. So, you will get the value like this, 1 over V1 square minus 1 over V2 square. So, you can see here the time of arrival of direct wave, reflected wave and refracted wave are different. So, if you put more number of receivers over a range of distance, and this is time, what you are going to get it? It will be like direct wave based on the time of arrival of which is picked up by the geophone. You can get like this will be direct wave, then there will be reflected wave, you can call it as direct wave. After a certain distance, reflected wave and direct wave will reach at same time. This is reflected wave. And then you will be having completely different way, you will be having refracted wave. It is observed like after certain distance, your refracted wave, because some component of refracted wave is travelling through stiffer medium. So, refracted wave will reach like at this distance, the refracted wave will reach much earlier than your direct wave. Again, you see here like this is the location at which direct wave and refracted wave both are reaching at same time. So, this distance will be called as DC. You can get it if you know from distance time curve obtained from number of geophones or same geophones kept over different distances and excited for same source. So, that is how you can get the value of DC. This will give you the value of 1 over V1, this is going to give you the value of 1 over V2, and so on. More number of sources are there, you will get more and more like this. This will be 1 over V3 and so on. Why I told you, because in the, if you remember the equation, DC by 2 plus DC by 2 times V2 minus V1 over V2 plus V1. So, the value of DC you can get from time distance curve, where the refracted and direct wave are meeting, and V1 value you can get as the inverse of the slope of first phase of field record, which is coming from direct wave starting from origin. V2 you can get from the inverse of the slope of second wave, that is refracted wave. So, once you know the value of V1, V2 and DC from your field record, that is how you can put in this equation and get the value of your thickness. Now, based on this, let us so we can go for seismic array, or you can go for geophone array, or even you can go for micro tremor records. Once you are interested to find out for subsurface exploration, subsoil exploration using shock waves. You can go with any of these. Now, let us see one example before going into detail. I mentioned here, so that you can understand how the seismic refraction survey we can do the interpretation. So, the problem is like a seismic refraction survey yields following times of arrival of P waves. So, you have put the sensors at different locations that you can understand from first column, and corresponding to each of the sensor, the time of arrival of P wave is detected. Based on this record, you are interested to find out the thickness and P wave velocities of the medium. Now, based on this time distance, first of all, in order to interpret where is the direct wave, where is the refracted wave, first of all we have to develop the distance time curve here. See, you see here I have just taken those values, you can simply take those values. The value of time is given in milliseconds, so be careful while giving the final values, and then distance is given in meters. So, you can simply put those values in Excel and you can get the value of distance time curve. Now, the first, as I mentioned here, because it is starting from origin, this is going to give you the value of 1 over V1, this is going to give you the value of 1 over V2. You know the values, you can directly get from the Excel sheet. Another thing you will be able to understand here, this is the value of DC, which is, if I remember, I got the value corresponding to 30 meter in this particular case. You yourself can determine the value. Like in this case, the time of this critical distance is matching with the geophone location. It may be possible like there is no geophone, but based on the interpretation of those, based on the intersection of these two slopes, you will be able to determine the value of DC. So, if I put here, if I know the value, so based on this, I got to know the value of DC, which is coming out as 30 meter. The value of V1 from this, I have estimated that is coming out to be 434.78 meter. You can put it in Excel, you can determine how much is the value of V1 meter per second. When you are converting, just make sure like this is given in milliseconds. So, you have to convert it into seconds in order to determine the value of V1. Similarly, the value of V2, which is the inverse of the slope of second part of the curve, which is given as 3529.41 meter per second. Now, you know the value of DC, you know the value of V1, V2, you can determine simply how much will be the thickness of this layer, that is layer 1, that is called as DC by 2, V2 minus V1 over V2 plus V1. So, I am just putting the values here, 30 by 2 times 3529.41 minus 434.78 divided by 3529.41 plus 434.78. If you put those values here, if you solve it, you will be able to understand the value is 13.25 meter. So, the stratification is like this and something. So, this is like soil 1 having V1 value or VP1 value equals to 434.78 meter per second, and this is soil 2 having VP2 or primary wave velocity as 3529.41 meter per second, and this is your layer thickness which you have estimated as 13.25 meter. There was a source here and there was a geophone which is kept at 30 meter, which is at critical distance. I am telling this thing is varying, so you need not put it. I am just going to give you what is the overall geometry of the site as obtained from seismic refraction survey. So, same way we can go for inclined method, I mean the base bedrock where or the interface which is inclined. Same way we can go for interpretation with respect to number of layers, but only thing which has to be mentioned here, the graph which I have shown here, it is showing very simplest case where you are having the refraction coming from the first interface. But if you put more number of this interfaces like from between soil layer 2 and 3, 3 and 4 and so on, there will be more sources for refraction, there will be similarly those sources will also act as sources for reflection. Same way, if you have some local pockets of denser material, that will again induce some more refraction and reflection from within the layers, which will be also getting detected at the same receivers. Another thing, if you have another source of vibration rather than this source, like some machine operation is happening in the adjacent region, because of which some shocks are generating and getting detected by the geophone, that will add more and more complexity to your field record. So, generally if you consider any typical field record, it may not look very streamlined like this, the field record I have shown here. So, you have to have more and more expertise whenever you are going for interpretation of field record for seismic methods. But I hope I tried, though it is giving you simplest case where you will be able to distinguish very clearly between direct wave and reflected or refracted wave. That will give you an understanding about how this method work, how this method is able to give you the subsurface investigation or subsurface properties, because this is the objective when we go for subsurface investigation. We have to find out different material, and depending upon again these properties, you will to determine whether this soil is soft, whether this soil is stiff, whether the soil is of the order of limestone or granite like this. Initially, I had given you some ranges of Vp value for different materials. So, comparing those values with this value, you will also get an idea what kind of soil medium is there existing below the ground surface, which you have probably explored based on your seismic refraction survey. So, thank you so much.